There's a huge problem in our contemporary society. While we fight for equality amongst all, we don't fight for the people who truly deserve it. We're discriminating against people who are inferior to us for no other reason than they were born that way. Paralyzed people. So while you're walking around having fun, paralyzed people can't even walk around and live their own life. They can't even be independent, they can't use the restroom, they can't eat alone. They always need someone to assist them to do everything. And that's unfair. And that's why we have created a wheelchair that uses eye track software to help them communicate with others and to help them move more freely. The first part of our wheelchair is the movement part. And so how did we do that? Well, we first coded the eye tracking. So we used a mixture of CNN models, convolutional neural networks, and OpenCV face detection, also DLib's face predictor model to accomplish this task. And so what the code does is, first it uses DLib's shape predictor model to take an outline of the user's face. So DLib's predictor has 68 key points on the face. They go all around and they go all around the face and the nose, the eyes, and the mouth. This makes the outline for the face. So we used the points that resembled the eye. Then we just masked out everything else using a convolutional neural network, and we contoured it so that the black and white from the pupil and the iris is all clear. Next, we just use a mathematical formula to detect how far the pupil has moved from the middle of the eye. So if I turn right, the pupil would have moved a certain amount from the center.
This is the first test for the Arduino Uno and the Python code working together, sending signals, serial signals from the Python code onto the Arduino Uno and controlling this servo motor. And so now if I look to the right, the motor will turn, and if I look to the left, the motor should turn the other way. The second part of our wheelchair is the communication mode. So how does it work? It's really simple. The communication mode allows the patient to communicate with their caretaker either by SMS or by voice. So let's take a walkthrough through it. This is the simple GUI we've decided to take. As you can see, the buttons are large so that the patient can easily maneuver. Right now, the mouse is being controlled just by my gaze, and so depending on where I'm looking, the mouse is moving and holding. Okay, so let's walk through it. So first, the patient will have to move his gaze onto the communication mode button and hold for 3 seconds. This is gonna take him to the next page, which has 3 options: either speak, SMS, or home. The speak option allows the patient to output a voice depending on the request they have. The SMS will send an SMS to their caretaker, and home will go back to the home screen you've seen previously. And so let's say the patient wants to speak. He's then greeted with 4 other options. Either the patient needs to use the restroom, wants a cup of water, has an emergency, or is hungry. So let's say that the patient is hungry. He's greeted with 3 final options. He's either hungry for fruits, snacks, or a meal. And so let's say he's hungry for a meal.
Can I have a meal?
A voice will be outputted through the speakers, and he's taken back to the home page to submit another request if he shall need it.
While this drawing might look complicated and hard, it's actually much more simple than you think. So it all starts here, our main control unit, the Raspberry Pi. So this Raspberry Pi has the eye tracking software built onto it, and it also outputs onto the screen, which has our communication mode. And so the communication mode has 2 outputs, either a speaker or an SMS message, depending on if the patient has a request or needs to send a message to the caretaker. So the communication mode part is done. Let's move on to the movement part. So the eye track software will then send a signal to the Arduino depending on the input. So if you look left, it's going to send a signal to the Arduino Uno that it's left, and otherwise it's going to send right. So from there, the Arduino would then output that signal onto the first motor drive, which controls the left and right movement. So the iTrack software will send it into the Raspberry Pi, into the Arduino, and into the first motor drive. But we also have another motor drive. This controls the thrust. This controls the forward and backward movement. This is not controlled by the Raspberry Pi, but actually from the blink sensor. And so the blink sensor can activate and deactivate the thrust. And so a blink or a wink would activate the motor drive, and the thrust would initiate. And another wink would then deactivate it, and the thrust would stop. But as you can see, we have some more sensors here. We have a gyroscope and an ultrasonic sensor. These control the Arduino Uno and both motor drives, because these will send signals to stop the motor drive just in case anything happens. Since safety is our primary concern, we still haven't tested our product on a real patient, someone who actually has paralysis. And that's because we want to make it as safe as possible and as accurate as possible. So until we fix it actually up to 100%, we won't be testing our product on any patient.